Okay guys, today, section 9.1, we're going to be talking about systems of equations in this unit. Okay? Now a system means just more than one equation, working with the same variables. Okay? So in this one you'll see that we've got an x and a y in each one of these equations. Alright? And let me ask you something. We've talked about linear and quadratic equations. What type of equations are these two that we're looking at right here? What type of are they linear? Are they quadratic? What do you think, Jordan?
They're linear.
They're linear because the highest power of x is 1, correct? Okay, now I'm going to write this a little bit bigger so you can see. I've got 2x minus y is equal to 8. That's one of the equations. And the other one is x plus y is equal to 1. Now Jordan just told us that these two equations are linear equations, so that when I graph them, they're lines. Okay? Now there are three things that can happen when I graph two linear equations. They can either intersect each other at one point, and that's what we're looking for. This point is called the solution to the system. Okay? It's x and it's y. It's the point that's on both lines. Okay? So, that's one thing that can happen. The two lines cross and they have a common point. Okay? The other thing that can happen, or the second thing that can happen, is that the two lines are parallel and they never cross. They won't have a common solution. Each of them have infinite solutions. Yes? There are an infinite number of points on each one of these lines. But they don't have a common solution. So we would say that there's no solution to the system. Each of the lines has infinite solutions, but they don't have a common solution. No common solution. Okay? Or the third thing that can happen, and we talked about this last year, is that once we graph the equations, we might find out that they are exactly the same. And they have infinitely common solutions. There's one graph is right on top of the other. So they can have one common solution. They can have no common solutions if they're parallel. Or they can have infinite common solutions if one is right on top of the other. Okay? Now the first method that we're going to talk about is the graphing method. And I can tell you, we're not going to want to use this. Okay? I'm going to teach you how to use other things that always get us to the right answer. But we're first going to graph it so we can get an idea of what it is we're doing. Okay? So, let's look at this one. I wrote them in different colors, and I'll graph them in different colors so we'll know which equation we're talking about. This first one, if I want to graph it, I need to put it in function form. So I'm going to subtract 2x from both sides. I'm going to get negative y equals negative 2x plus 8. Then I'm going to divide everything by negative 1. And I'm going to get y is equal to 2 over 1x minus 8. Okay? So when I graph that, I'm going to go down 8. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put my dot right there. Then I'm going to go up 2 and over 1. Up 2 and over 1. Up 2 and over 1. And you know what? I'm going to use the line to help graph this thing. And hopefully I'll get something pretty straight there. Okay? And I'm going to cover it over with red. Okay. That's pretty good. Now let's look at the green one. To put that one in function form, I need to subtract x from both sides. I'm going to get y is equal to negative x plus 1. And guys, when I write that with slope in it, it's negative 1 over 1x plus 1. Okay? So now the graph for this one, I go up 1. And then my slope is down 1 over 1. Down 1 over 1. Down 1 over 1. Uh-oh. Uh-oh. I already see the point they have in common. Do you see the point they have in common? They cross right here. Now, let me write the coordinates for that. The x is 3, and the y is negative 2. So the solution to this system is 3, negative 2. That's the point that they have in common.